So we want to identify vertical and horizontal asymptotes for this rational function. So what I want to do is I want to factor the numerator and the denominator. Let's look at the bottom first. X squared minus 4x minus 5. First term here, x squared. Last term here, negative 5. Middle term, negative 4x. How do we build x squared? That's x times x. Minus 5, how about negative 5 times positive 1? I think that'll work. Negative 5 times x. Negative 5x, positive 1 times x, positive 1x adds up to negative 4x. That gives me x minus 5 times x plus 1. So that's the bottom. Now, dealing with the numerator, the top, we have negative 2 x squared minus 2x plus 24. The first thing I'm going to do is I'm going to factor out the common factor of negative 2, which will give me x squared plus x minus 12. Always check. Negative 2 times x squared is negative 2x squared. Negative 2 times x is negative 2x. Negative 2 times negative 12 is 24. Then I need to factor this. So what is that going to be? Again, using my factor box. I have x squared here minus 12 plus x. X times x plus 4 times minus 3. I get plus 4x and minus 3x is plus x. So x plus 4 times x minus 3 is what this becomes. But don't forget the minus 2. So we have negative 2 times x plus 4 times x minus 3. So let's rewrite this function r of x as the numerator divided by the denominator. So here is where we are. R of x equals numerator negative 2 times x plus 4 times x minus 3 divided by x minus 5, x plus 1. Nothing divides out. So in terms of the vertical asymptotes, we look at the bottom. And we know x minus 5 can't be 0. So if x minus 5 is 0, that's a problem. We know x plus 1 can't be 0 in the domain. So if x plus 1 is 0, that's a problem. So we have a vertical asymptote at x equals 5 and at x equals negative 1. Now what about the horizontal asymptotes? I want to go back to the original version of this. So we get negative 2 x squared minus 2x plus 24 divided by x squared minus 4x minus 5. The degree of the top and the bottom is the same. The degree of the top is 2, the degree of the bottom is 2. When that happens, when they're the same, we will have a horizontal asymptote, but here's the way you have to think about this. If x is a very large number like 1,000, 1,000 squared is 1,000,000. So as far as 1,000,000 is concerned, 1,000 is kind of irrelevant. So what you do is you just focus on the highest parts. So because they're so much bigger, 1,000,000 squared is 1,000,000,000,000, I believe. So these earlier parts are kind of irrelevant. So for very, very large numbers, the function is basically negative 2x squared over x squared, and the x squareds are divided out to give you negative 2. So my horizontal asymptote is at y equals negative 2. So let's take a look. Let's go ahead and put this on Desmos and see what the graphs look like. So we have r of x equals upstairs negative 2x squared minus 2x plus 24 divided by downstairs x squared minus 4x minus 5. And do we see the asymptotes as we said? Now let's make sure we have a window that we can work with here. I think maybe I'm going to get a little bit more in the y direction. So maybe we'll go with negative 16 to 16. We'll just double the size of our y's here, just so we can see what's happening. I'd feel better, though, if I could still see. There we go. That's pretty good. So where did we say we had vertical asymptotes? We said x equals 5. Take a look. X equals 5. Does that look like an asymptote? I think so. So x equals 5 there. Looks like an asymptote. Where else did we say we had an asymptote? We said we had one at x equals -1. What do you think? X equal -1 look pretty good. Let's go ahead and put that in. Now, the horizontal asymptote's a little harder to see here, so I think I need more x to be able to identify that. So we see our two vertical asymptotes there as we expected. Let me get some more x. So maybe we'll go negative 16 to 16 on x as well. Good enough to see the vertical asymptote? Maybe. What did we say the vertical asymptote was? We said it was y equals -2. And yeah, I'd say that looks reasonable. We want to even have more y. We could see that. So we could go negative 50 to 50. Whoops, that's not what I wanted. I wanted the x-axis to change. Negative 50 to 50. And now you can really see that y equals -2 asymptote showing up there. So what can we say about this? That's our problem. To get the vertical asymptotes, again, look at the bottoms. Make sure that you identify where the bottoms are 0, and as long as it doesn't divide out, that'll be a vertical asymptote. Horizontal asymptote, if the degrees are the same top and bottom, ignore all the earlier parts and divide, in that case y equals -2. If you had a higher degree on the bottom than the top, then your horizontal asymptote is just going to be the x-axis, or the line y equals 0. Just take a quick look on that. How do I change that? Problem on our thing here. You'll notice I have order 2, order 2. If I want to make the x-axis the horizontal asymptote, give me a higher power downstairs, right? So once they have a higher power downstairs, you ignore the earlier or lower parts. You have basically 2x squared over x cubed, or essentially -2 over x, which will go to 0 as x gets large. So higher power downstairs, x-axis is a horizontal asymptote. That, of course, is the line y equals 0.